In this video, we're given some functions and we have to determine if these functions are one-to-one. So you can look at the functions given. Again, these are all functions, six of them. Okay, so let's go through these. A quick review though. So we're given functions and we want to determine if they're one-to-one. So first let's look at what a function is. The first one, of course, we have a polynomial function f of x equal to x squared, a parabola with vertex at the origin 0, 0. So if we go over, say, 2 units, put x where the 2 where the x is, that's 2 squared. So this would be the point 2, 4. And if I go 2 units over here on this side, that'd be -2. -2 squared is still 4. So this point up here will be the point -2 and 4. So by definition, a function is such that for every x, there is just one value of y. So I go up to the right, or to the right 1 unit or 2 units. I go 1 up. To the left, I can go 1, 2 units, and I go 1 up. For every x, there's going to be one value of y. Over here, the same thing for this one. F of x equals x to the third. If I go so many units to the right, I go so many units up. There's only one value for y. If I go to the left, so many units, I go down. There's a corresponding point for that value. For every x, there's one y. A function is one-to-one if for every y, there's only one x. So if you look at the first one here, this one has the point -2, 4 and 2, 4. So if I connect those 2 points there, when y is equal to 4, there are 2 values for x, a -2 and a +2. So this function here is not one-to-one. So again, the definition of a function is such that for every x, there's one value of y. Now the function is one-to-one if the converse is true also. For every y, there's only one value of x. For the first one, it's not true. For the second one, it is. I go over here, I go up. Over here, go up. In each case, for each value I pick for x, there's just going to be one distinct value for y. So there's a test that they tell you about. A function is such that a vertical line crosses the graph at one point. So you look at the graph of the parabola f of x equals x squared. A vertical line crosses the graph at one point. Function over here, this one, this is function. Vertical line crosses one point. But if there's a horizontal line that crosses the graph at more than one point, that's here, here, for example, or here, here, that's going to tell you that when you pick a certain value for y, there won't be just one value for x all the time. Okay, so it's not going to be one-to-one. So if you know what the graph looks like, you can do a visual. If it's a one-to-one function, a horizontal line has to cross at one point. So a vertical line crosses the graph of a function at one point, and if it's one-to-one, a horizontal line will cross at one point. So notice this one here, and you draw any horizontal line, it crosses the graph only at one point. So that tells you that when you pick any value for y, there's only one value for x. So let's go and look at the examples we have. Y equal x squared plus 6. Well, from what we did so far, you know that y equal x squared is a parabola. If you add 6 to it, it simply moves the parabola up 6 units. It's still going to have this shape. So it's going to fail the horizontal line test. Okay, it is a function, but it's not one-to-one. So for this one, we say no, not one-to-one. Now number 2, y equal 3x minus 2. You should recognize that it's linear. You should recognize it as a straight line. The slope is positive, so basically you have a line that rises, something like that. It's a function, so we know it has to pass the vertical line test, and it's got to pass the horizontal line test. So this one is one-to-one. Yes, y equal 3x minus 2 is a one-to-one function. The second one, y equal 5 to the x. You should recognize that as an exponential. So notice if you pick x to be 0, 5 to the 0 is 1. So the graph passes through 0, 1. And as x gets larger, 5 to the x gets larger, so this graph is rising, going out something like that. And as x gets small, go to the negative side, 5 to the negative 1 is 1 over 5. 5 to the negative 2 is 1 over 25. So as x gets negative to the left, the values of x, I should say, or y, are getting smaller, and they approach the x-axis. Never touches. So the x-axis is a horizontal asymptote, but it passes the horizontal line test. So it is 1 to 1. So this one is yes. That's 1 to 1. Y equal the log of x to base 7. The graph y equal log x to base 7. If we go 1 over the log of 1 to base 7 is 0, because 7 to the 0 is 1. So the graph is going to pass to that point. You can't have a log of a negative, so it's going to stay to the right of the y-axis. And it's going to go something like this. You can plot a few points or use your calculator, but the graph looks something like that. The y-axis is a vertical asymptote. It approaches from the right, and then it rises. It passes the horizontal line test. Horizontal line passes that crosses the graph at one point. So this is 1 to 1. That's 1 to 1. Now we look at the next one, y equals 7. That's the graph of a line. It's a horizontal line. So go 7 units up here, so 7 units here. It's a function. Vertical line crosses it at one point, but see, if I put a horizontal line on top of it, it intersects it at a bunch of points. So y equals 7 is a function, but it's not 1 to 1. So this one, no, it's not 1 to 1. Y equal x to the third. Well, we saw the graph of y equal x to the third minus 5. It's pretty much the same type of graph as the one we saw earlier. It just goes 5 units down. So the graph is going to go something like that. I could graph it over here. Y equal x to the third basically goes this way like that. Passes through the origin. And this one simply goes 5 units down. Same thing, move this down 5 units, passes right there. Negative 5, goes up like that. That one is 1 to 1. So the answer to this one is yes, it is 1 to 1. Now, one of the things you should know, if you haven't already covered it, if a function is 1 to 1, it's going to have an inverse function. Okay, so only functions that are 1 to 1 will have an inverse function. If it's not a 1 to 1 function, it could still have an inverse, but it's not going to be a function. It'll be a relation. Thanks for watching. We'll see you next time.